In this video, we will discuss about largest combination with bitwise and greater than 0. The bitwise and of an array nums is the bitwise and of all integers in nums. You are given an array of positive integer candidates. Evaluate the bitwise and of every combination of numbers of candidates. Each number in candidates may only be used once in each combination. Return the size of the largest combination of candidates with a bitwise and greater than 0. So what they are saying is that in the input, we are given an integer array named candidates. What we need to do is we need to find out all the combinations of this array, right? And in that, for every combination, we need to find out the bitwise and of the numbers in all that combinations, right? And then in whichever combinations, the bitwise and is greater than 0. Out of them, whichever has the greater number of elements, that number of elements we need to return as our answer. So basically in simple language, what they are saying is that this is the array that is given to us. Now, if we try to find out the possible combinations of this, then it can be 6 alone, 5 alone, 4 alone, 3 alone, then 6 and 5, 6 and 4, 6 and 3, then 6, 5 and 4, or 6, 5 and 3, or 5, 4, or 5, 3, and so on. So there are so many combinations of all these elements. Now, out of all these combinations, you need to find out the bitwise and of all these, right? So in this particular combination, you will find out the bitwise and of 6 and 5. Here you will find out the bitwise and of 3, which will be 3 only. Here you will find the bitwise and of 6, 5 and 4, right? So for every combination, you need to find out the bitwise and. Now after these, out of all of these combinations, whichever are giving you the bitwise and greater than 0, for them you need to find out which one is having greater number of elements. For example, if let's suppose this 6, 3 and 6, 5, 4, this is giving you a bitwise and which is greater than 0. Then in these, this one is having 2 elements and this one is having 3 elements. Which is having more number of elements? This one, right? And it is 3. So we need to return our answer as 3. So that is what the question is asking us to do. So now if you see here, what we did was we identified all the combinations and then we did the bitwise and of all the elements in all the combinations. Then we find out, okay, what all combinations are having their bitwise and greater than 0, and then out of them, which is the combination that is having the largest number of elements. After doing all this entire process, we were able to get our answer. So this will be a very lengthy and complex approach, right? So we will have to think of something better, right? So let's try to find out some hint from the question. So the question says that we need to find such a combination where the bitwise and of all the elements is greater than 0, right? Can I say that the bitwise and should not be equals to 0, right? Both of these are one and the same thing, right? Now these numbers, if you see, these numbers that are given to you, so these are 3-bit numbers in binary, right? So I'm saying that whatever combination I am taking of these numbers, their and should not be equals to this, right? Their and should not be equals to this. Other than this, it can be anything. I can have 0, 1, 0. I can have 0, 0, 1. I can have 1, 0, 0. Right? Anything it can be, but not 0, 0, 0. Right? So that means in my bitwise and, there should be at least one bit that is set, right? If there is at least one bit that is set in my bitwise and, then I can count it as a valid bitwise and, right? So basically this will also work, this will also work, this will also work, right? And this is also going to work, this is also going to work, all of these are going to work, right? Meaning if there is at least one bit set in my bitwise and, then it is one of the valid bitwise and for me, right? I don't care what other bits are, there should be at least one bit set, right? If in my and there is one bit set, at least one bit set, then I don't care what is present at the other places, right? Because if there is at least one bit that is set, then my bitwise and is not equals to 0, right? So can I say that you need to identify such a combination where the bitwise and has at least one bit set, right? Simple. So now let's see how does the truth table of bitwise and looks like. So whenever the two bits are 0 and 0, it gives us 0. Whenever one of them is 0 and one of them is 1, then it also gives 0. And when both of them are 1, only then it gives us 1, right? This is the truth table of AND. When do you get a particular bit as 1? If that particular bit in all the numbers of whom you are doing the bitwise AND is also 1 for all of them. Because if any one of them is having that particular bit as 0, then this bitwise AND bit is not going to be 1. It will be 0 only. Then that means whatever numbers I am taking into consideration for a particular combination, all those numbers should have a particular place in their binary representation where all of them are having the bit as 1. Meaning, if let's suppose I am having these two numbers, right? Now in this, if you will do the bitwise AND, you will get 0, 0, 0, right? Because there was no place where the bit was 1 in both the numbers, right? But if I consider this one, if I consider this, then what will happen? We will get 1, 0, 0, right? Because this place was having 1 in both of the numbers. That is why I got 1 here, and here my bitwise AND is not equals to 0, right? So I just need to identify a combination where all the numbers are having at least one bit set at the common place, at the same place. Right, so let's remove this now. So now what I am saying is that the maximum element that you can get in your array is given as 10 to the power 7 in the constraints. Right, 10 to the power 7 is represented with 24 bits in binary. Right, that means you will have at max 24 bits to compare. Right, so what you need to do is you just need to identify what all numbers share bit 1 at the common place. Meaning I am having 24 places, right? So my bit positions will be 0, 1, 2, 3, 4, 5, 6, and so on till 23, right? These are the bits that I can have. Now, what you can check is that, okay, for the 0th bit, how many numbers are there out of this array which have the 0th bit as 1, right? Then similarly, you can check for the bit 1 that how many numbers are there in this array who have the bit as 1 at this first place, right? Then again for this bit, you can check how many numbers are there which have their bit as 1 at this particular place, right? And then you can check this thing for all these bits, right? From 0 to 23. Then for every bit position, you will be having the number of elements which are having their bit as 1 at that particular place, right? So what you can do is you can just identify that out of these 23, whichever is having the maximum number of elements, that is going to be your answer, right? Because I told you here that there should be at least one bit set, and I don't care what the other bits are. If at least one bit is set, I can say that this is one of the valid bitwise AND. I don't care what the other bits are, right? So if I am checking for this particular place, if I am checking that, okay, what all elements are there which are having 1 at this particular position in their binary representation, I can do that because I don't care what is present at the other places, right? I only care about this 0th bit. I don't care what is present at the first bit or the second bit or the third bit, right? If all of the numbers are having their 0th bit set, then they will always give me a bitwise AND which is greater than 0, right? So I will count them. Again for 1, if I know that all these numbers are having their first bit as set, they will always give me bitwise AND greater than 0. So basically you can identify this count for all these 23 bits, and then for whichever bit you are having maximum number of elements, that number of elements is going to be your answer, right? So if we see for the test case that is given to us, so 6 in binary is written as 110, 5 is written as 100, 4 is written as 101, and 3 is written as 011. Right. So if we see, this is the 0th bit, this is the first bit, and this is the second bit. Right. So now for the 0th bit, if you see, we are having two elements which are having their bit as set. Meaning for 0th bit, we are having two elements. Then if we see for the first bit, then again there are two elements. Right. So for the first bit, we have two elements. Then for the second bit, if we see, we are having three elements, right? So for the second bit, we have three elements who have their bit as set, right? So now out of these, which one is maximum? 3, right? So this 3 is going to be our answer, right? So you just need to run a for loop which will run for the 24 bits, right? It will run from 0 to 24, and then you can check if, let us suppose, 0 to 24 we are running for a variable I, then you just need to check that for all these numbers, how many of them are there which are having their ith bit as set. Then whatever is that count, that count you can take and update your maximum variable. So let's suppose you are taking a variable maxi, then you can update that maxi with the maximum of maxi comma whatever is the count that you have got. That is the simple thing that you need to do. So let's code it out now. You will be able to understand more better. So what we'll do is that first of all, we'll create a max count variable which will store the maximum number of elements that we have got in any case, right? Then we need to run a for loop for our bits. So it will start from 0 and it will go till 23. So less than 24. And then we'll do I plus plus. Right now inside this, for this particular bit, for the ith bit, we need to count how many elements have their ith bit set, right? So we'll create another variable count equals to 0, right? Then we will run a loop inside our candidates. So it will be int num in candidates, right? Now inside this, we need to check that if in this particular number num is the ith bit set or not. For checking whether the ith bit is set or not for a particular number, we have a formula which is num bitwise and of 1 left shift I is not equals to 0. So basically this formula tells us whether the ith bit of this particular number is set or not, right? So if it is set, then we'll do count plus plus. If it is not equals to 0, then we are doing count plus plus. And once we have identified for all the numbers, we will update our max count. So max count will be equals to maximum of max count comma count, right? And at the end, you can return your max count, right? Let's run this. So if you closely look here, that here we are running a for loop which is running 24 times, right? And this for loop is running n times, where n is the number of elements in the candidates vector, right? So what will be your time complexity? It will be order of 24 into n, right? Now since 24 is a constant, can we say that the time complexity of our code is going to be order of n, linear, right? And what is the space complexity? We are not using any other extra space, right? So our space complexity is also constant. So let's submit this now. So it got accepted. Thank you so much for watching. Please like the video and subscribe the channel.